Well, this is some crazy video that I did when too late. Maybe I was too tired, that's a little bit drunk, you can say, but I went to get the feeling of the triangle operator, what I call the triangle operator. The triangle operator is something that acting on the variable x produce, you imagine a drop, when it touch, it produce x2 minus x1, x2 minus x1. It produce an interval here, x2 and x1. So it open the x-axis and create 2 points, and the 2 points are this. So what we are going to do is to play with the delta, as delta is an operator that is applied to x, will produce delta x, x2 minus x1. It applied to y, it'll produce delta y, y2 minus y1. And when y is a function of x, let's say ax squared, if I apply the operator to y, how it will affect delta to the x squared. So we imagine that it's working like an operator. Yes, I play with this and taking on account always that this is what we are doing, the final point equal to the initial point plus the change. How big is delta x? We try to visualize delta x very, very small around the point x. This is the idea, to go to the limit of delta x 0. But to go to the limit delta x 0, it doesn't mean at all that delta x is equal 0. No. We go to a small delta x. With the time, we'll do the same thing. This is the time. We'll apply the delta operator in a point, and when it applies, it will appear T1 and T2. So delta applied to T will be T2 minus T1. So we want to know if we have an equation like x of t equals 3t squared, and we apply the delta operator to x of t, how it will be affected when we will do 3 delta of 3 of t squared. So this is what we want to find. And why we want to find this? Because we want to find delta x divided by delta t, the slope of the curve. And why we want to find here this? Because we want to find delta y divided by delta x in this case. This is the input, this is the output y. This is the input t, and this is the output, and this is the output x. So I want you to be sure it's a little bit strange video, maybe the most strange video that I have done from the moment, but maybe the chaotic way to explain things will help you to understand a little bit more. I hope you enjoy. So I want to be sure that you differentiate between the input and the output. If you have, for example, a function that is y of t, t is the input, y is the output. So at certain times t, you will have the input, and the input will produce an output that will be in the y-x. So if t is equal to t1, you produce an input, let's say this one. You produce if t1 is the input, you produce an output that is I1. And if t equal t2 is the input, you produce another output that maybe is this one. So it will go to this point, y2. So between t1 and t2, there is a delta t. And between y2 and y1, there is a delta I. And I want to find delta y by delta x, depending of the curve that I'm treating. This would be something, and what I want to find is the change in the output when I change the input. So, so imagine now that my function is not y of t, it's x of t. T is the independent variable, is the input. In this case, x is the output. What I want to find is what? Is delta x divided by delta t. So suppose that you are at this t1, it would produce an output that will be x1. When you are in t2, would produce an output that will be x2. And I want to make a relation between delta t, this delta t, and delta x. So once that I find the relation, I can find delta x divided by delta t. So I will find in the picture, I will find delta x divided by delta t. And why I want to find the change in the output when I change the input? Why? Because things are alive. I need to know what are the consequences. The consequences, for example, in the stock market, if the value is going like this, the consequences is that if you are at the time t, and this is the value of the stock market, let's say the Dow Jones index. So if you go and you find the value at this exactly moment is this one. But if you are here, for example, if you are here, the value will be bigger. But what happens? If you are near this point and you make a small step, only this quantity will increase. But if you are here at this time t and you make a small step also, you will change a better increase in delta y of the value. So delta y by delta t will depend on the points where you are, if it's not a rectilinear line. In conclusion, delta x divided by delta t is the measure of the velocity of change. This is the velocity of change of x. If it's delta v, if it's another, this is the velocity of change of the variable x respect to t. Here, on delta y of divided by delta x is the velocity of change of y when x change. So let's go. To see. So, for example, let's say function of velocity. A vector velocity have two components, the component vx and the component vy. So normally we express the vector velocity like some quantity, velocity vector in the x direction. I plus some quantity v sub I in the j direction. And it could happen that this v sub x and v sub y, it could be function of time. Maybe they are not constants, like a vector 3i plus 4j. Maybe this is a function, maybe it's 3t and 5t or 3t squared. So it's changing. Vx is changing with time and Vy is changing with time. So I want to find for Vx, for example, I would like to find if delta t change, how will change delta Vx? And I want to find if delta t change, how it will find delta Vy. And I want to find delta Vx divided by delta t. And I want to find delta Vy divided by delta t. And this is the slope of the function. So if you have a function, for example, the acceleration function, it could happen that a will be the acceleration vector. This is always axi plus ayj. It's a vector that has components in the y and the j direction. And it could happen that ax depends on t and ay depends on t. So I have to separate and to analyze how a change in delta t will make a change in delta a x, how a change in delta t will produce a change in delta ay, and to divide delta ax divided by delta t. Normally, we are not, we don't use, we don't care about the change in acceleration respect to time. This slope is not a slope that physically they say something. I don't know why, but I don't find any equation. Well, any equation that relates the change in the acceleration with the change in time. So let's make some picture here. Yes, we make some pictures. So this is the vector v. So the vector v have components vx and vy. Vx can change with time. Maybe not. Maybe it's something like this. Vx never change with time. Maybe it never change with time. So if it's never change with time, it's because it's constant. So this is the graph of Vx equal constant. Something that always the value is 3 meters per second. So Vx is constant. But maybe By change with time. Why will By will change with time? Well, because there is a force in this direction y that is making the object to change the velocity. If there is Vy and Vy is not a horizontal line, maybe it's this line. So if it's this line, a rectilinear line, I will choose 2 points, T1 and T2. I will see what is Vy at time T1. I will see what is Vy at time T2. And I will ask myself, what is the change of Vy respect to time? When the time delta t pass, what is the change? So I will see that is this one divided by this one. This is delta Vy divided by delta t. So if this is a rectilinear line, Vy have the force, By of t have the force, a constant b, that in this case will be V0y, plus the slope. The slope is what we call the acceleration. The acceleration is the slope here. dy divided by dx by ddt. So v sub I, the equation for this rectilinear line is Vy of t is V0y, let me use another color, plus the acceleration, that is the slope, that I can put it like this because it's constant, ddvy divided by ddt multiplied by ddt. You will think, well, this will go with this. Yes, it's true. It will go. This is the equation. This is the equation. Vy of t equal a by delta t. So we will see later this equation. There are the possibility that Vy as a function of t is not a rectilinear line, like for example something like this. In this case, the change in v respect to time is always changing. So the acceleration is changing. If v sub y is like this, and as a function of t, the change will be this quantity divided by this quantity. But if you do it through the curve on this time t1 and T2, and you use the same delta t, you will see that this quantity is bigger, so the slope has been bigger. So if the acceleration is the measure of the slope, in this area, the slope is bigger than in this area at the beginning. So let's go to the next page to see what's going on. That says something. So, being said this, we are interested to know the following. Suppose that we have a function like this one is a rectilinear line. And we want, if x change in delta x, how will change delta y? So if x change from x to x plus delta x, what will happen to delta y? And the game with delta x is like this. If you take delta y, you take the function y equals 3x plus 5, and you take delta y, you make it like this, delta of 3x plus 5. And delta y, that is what I want to find, delta y is the output to delta x, is delta of 3x plus delta of 5. But delta of 5 is the change in the number 5. But if the 5 is constant, the change of the number 5 is 0. So delta y will be 3 times delta x. So delta y divided by delta x will be 3. And 3 is the slope of this function. So I have found, using the operator delta, what is the slope of this curve? And the slope is delta y divided by delta x, and I know, and I knew before of doing that delta y by delta x will be 3. So, so you have to realize that the value of delta y and delta x will depend on the shape of the curve that you have. The shape will decide how is delta y and delta x, but not only the change, the position where you are in the independent variable will decide how much will be delta y divided by delta x. So, the quantity that we are looking is delta y divided by delta x. This is the quantity. This is y2 minus y1, x2 minus x1, or maybe the function is x of t, and the quantity we are looking is delta x divided by delta t. So it could be also x of t, and this is the change in the dependent variable respect to the change in the independent variable will be x2 minus x1 divided by t2 minus t1. So the thing that we are going to learn is how delta is acting. It acts on the variable x, on the independent variable, and produce and induce a delta y. If x of t is 20t, we already did it. Again, delta x, the change in x, is the change on 20t. It will be 20 times delta t. So delta x will be 20 times delta t. And delta x divided by 12, delta t will be 20. That is exactly the slope of the curve. So from t1 equal 1, x is 20, from t2 equal. So if I make this delta, the equation say that delta x divided by delta t is 20. It doesn't say that delta x divided by delta t is 20 times t, for example. It says 20, no t, 20 is a constant. So if we check, for example, between t1, when t1 is 1 and t2 is 2, x1, x2 is 40, and x1 is 20, so the change in delta x divided by the change in delta t will be, the change in delta t will be 1, and the change in delta x will be 20, so 20 divided by 1 is 20. So this is delta x divided by delta t, and this is the same thing than this. If we do it between any other points, for example, for t equal 1 when the value is 20 and t equal 3 when the value is 60, delta x divided by delta t, the slope is also 20. It doesn't change for a rectilinear line. To change the slope, you need to twist the curve. If you twist the curve, you change the slope. Always, always. There is no other way. Here is the same thing. Now the curve is a curve that has a slope negative. It's going down. It's not going up. So the slope is negative. And why the slope is negative? Because you go to any points. Here, for example, here, you go here. When delta t change from here to here, the slope going down. It says delta x is negative. Delta t is always positive, but delta x is negative. So that will mean that delta x divided by delta t will be negative. What it means is average velocity that is negative. It means that the object is going in this direction, going to the negative. If you take the slope here, between these 2 points here, also delta x is negative and delta t is positive. So the particle that is described by this equation is going in this direction. V is going in this direction. V sub x, sorry, V sub x. So we make the slope the same thing here, and we make the same thing for the slope. We will find that if this is the case of the equation, we found B, and this is the equation for this particular case. I think that I did it correctly, but you can find the equation that passed from these 2 points, the rectilinear line that passed through this point, because you know how to calculate because we have done in unit 1. So if you find the equation, it will be like this. So m is clear that it's minus 20, and is constant, is negative and is constant. So wherever you see a curve that is going down, you know that the slope is negative. Okay. Okay. So conclusion. In a graph where it appears the input t and the output x, the input t and the output x, when you measure the slope delta x with delta t, you measure the slope of the graph x of t. If you take delta t very small, you measure the slope near the point. So the slope can be positive. Can be positive if delta x is positive, only if delta x is positive, because delta t is always positive. And in this case, if delta x divided by delta t is positive, it's because the curve x of t is increscendo, so delta x divided by delta t will be positive. But if delta x divided by delta t is negative, is because delta t is always positive, so delta x will be negative if this quantity is negative. And this will mean that the average velocity will be negative. And a negative velocity means that the object is moving in the direction minus I. Okay, this is the direction. Minus I is going in the x-axis, moving in the minus I direction, negative direction. So if you are here, 0, this is the x-axis. If the velocity is negative, it's because the object is moving in the minus I direction. If you are here and x negative, and a slope negative in the graph x of t, is meaning that the object is moving in the minus I direction. It doesn't depend where the object is. If the slope is negative, the object is moving in the negative direction. This is the positive, this is I, so it's moving in the minus I direction. If the slope is positive, it's because the object is moving to the right. Even if it's here or wherever it is moving to the right. So this is v delta x by delta t positive. Okay, I hope you catch it. I hope you catch it. Let's go to do this problem. Let's say that this is where I want to arrive. Let's say now that x of t is 3t squared plus 10. What is delta x? Delta x is what I found, the output. I want to find delta x if I make a change in delta t. Will be delta of 3t squared plus t plus 10. Will be 3 times out delta t squared. Delta t squared, let's go to put it like this, delta of the t squared, okay, plus delta 10, but delta 10 I said is 0, so this will be 0, so it will be 3 times delta of t squared. So I want to find this delta of t squared, so delta x, the output of the function, when I change t in delta t, will be 3 times. What will be delta t squared? Well, if delta t is t final minus t initial, delta t squared will be t squared final minus t initial squared. Okay, well, delta t will be like this. Delta t squared will be t final minus t initial, but t final is t initial plus the change. T initial plus the change squared minus t initial squared. So delta x will be, if I develop this and I take this one, delta x will be 3 times. 2 times t1 and t1 squared will go out. And this is the point. If I consider a delta t very, very small, meanings if delta t is very small, if delta t is very, very small, delta t squared is very, very small compared to delta t. So what we do is like this. We try to see very, very near the point, and we try to see what is delta x divided by delta t. So we have delta x equal this expression. You can reduce this expression to this expression. But if delta t is very, very small, delta t squared will be less than delta t. So we can, in some way, we can forget this term. We can forget this term because this term is very, very small compared to this term that depends on delta t. So in this case, delta x divided by delta t will be 60. These say that the slope depends on the point t that you are. If you are in t equal 1 second, delta x divided by delta t will be 6 times, by 6 by 1. But if you are in t equal 2, delta x divided by delta t will be 12 times. So you can see in the picture that it's not the same to make delta x divided by delta t around this point, that around this point. Because if I do it around this point, I will do delta x divided by delta t. But if I do it around this point, I will do delta x very big divided by delta t. So it's not the same. It depends, the slope will depend on the point that you are. And it will depend on, according to this equation for this graph. Okay. So, I want you to think of this. I'm not going to finish it. I want you to check if you can get the idea. Let's say that we have this function y of t equal y0. At t equals 0, the initial value is y0, let's say 100 meters. At t equals 0, 0 here, 0 here, 0 here, the initial value is y0. As the time is passing, the value of y is going down in this quantity, 1/2 at squared. As times go, the value of the y is going to be less and less and less. Even here is 0, the value of y. And after some time, the value of y will be negative value. So this is the y-axis. So let's see, let's check if I want, and this is what I want you to do it. If I change the time in delta t, how it will change delta y? And I want you to calculate how is delta y divided by delta t. And this will give you, if you do it for short time, will give you the velocity on the y-axis. It will give you this velocity at this point. It will give you, if you do it around here, it will give you what we call the instantaneous velocity v sub y, the component of the velocity in the y direction. So play to find delta y divided by delta t, play to find delta y divided by delta t, and makes calculation. Let's say that your curve is like this, make y of t equal 100 minus 10 times t squared. Draw this picture, draw this graph, make for t equal 1, approximate the speed v sub y at t equal 1. Meaning that you have to make the change, delta y divided by delta t, and find delta y, by when delta t is very small. Make the same thing for t equal 2. What is v sub y? And let me know how you do it. It's almost done here. I'm too tired. It's almost done here. You can do it. You can do it. You can do it. I know that. Okay, good luck. Do not worry if you don't understand this equation, because we are going to see again this equation, and we are going to deduce how this equation is come from. Okay? Do not worry. Just I want you to have the touch. This equation belongs to an object that is falling down under the attraction of the Earth, of the gravity. This is the acceleration A. I approximate to 10. And the object is initially at this height, is coming down, and every time he got more distance, more delta y in the same times, more delta y in the same time, more delta y in the same time. It means that the velocity in the y direction is increasing, and I want you to make an approximation for this curve, how the velocity will be here if the curve is y of t like this. Okay, just to find the slope, to give the idea what the slope is. And the slope, if it's negative, it will tell you that the object is going down in the minus, well, in this case, negative means in the minus j direction, not in the minus I direction. Okay, good luck. I'm too tired because I'm too tired. I'll see.